Hello my dear students. In today's video we will study about simple microscope. Microscopes are used to enlarge small objects and view them clearly. What is a simple microscope? Actually it is a converging lens, a convex lens of small focal length. To get proper magnification, what we have to do is we have to keep the object at F or within F. Just before F we have to keep. So these are the two cases where the positioning of object is done. In case 1 we will study the object is kept just before F, and the case 2 we will learn when it is kept at F. Now the eye has to be placed very close to the lens on the other side, that is in the near point. Now we will discuss if the object is placed within focus of the lens, how will be the image formed. This diagram over here shows the magnification produced by a simple microscope. So we can see here the object is kept at a distance u, which is within the focus, and the image is formed at the same side, in the same side at a distance d, d meaning least distance of distinct vision. That is, for a normal eye it will be 25 centimeter. Without strain we can see the image. It's a virtual image and an erect image. The eye is focused on the other side at the near point. Now we will find out the magnification with the help of this ray diagram. From this ray diagram we can find out the magnification produced for the object which is kept at a distance u, that is within the focus of the convex lens. See here the image is formed at least distance of distinct vision. So what will we do is we'll write the lens equation first, that is 1 by v minus 1 by u is equal to 1 by f. Now this first equation we will multiply by v on all the terms. So it is v by v minus v by u is equal to v by f. So that is 1 minus v by u is equal to v by f we got. What is v by u? V by u is nothing but the magnification, linear magnification. So we can say equation 2 is 1 minus m is equal to v by f. But you can see here the image is formed at least distance of distinct vision here. That is on the left side of the lens, but the ray is going towards the right here. So that means it is a minus d. So that means it will be minus d by f on the right hand side. So when we change the sides and write m is equal to 1 plus d by f. This is the magnification, linear magnification produced by a simple microscope when the object is kept within the focus and the image is formed at least distance of distinct vision. In case 2, if the object is placed at a distance f, where will be the image formed and how will be the magnification? That is what we have to find out. So when the object is kept at f, the image is usually found to be at infinity. So this adjustment of the microscope is called normal adjustment. Why we are doing so is because in this adjustment the eye will be very relaxed to see the image. So here what will we do first is we will keep the object at d distance away from our lens, as well as our eye will be very close to the lens. So the object is supposed to be at d first. So what is the angle made by the object we will find out. So see here, this is the position of the object initially. So what is the angle it makes with the eye as well as the lens is theta O. This is the object for us first. Now what will we do is we will slip the object near to F. Okay, so when F, the object is shifted to F, the image will be formed at infinity. You can see the parallel rays coming in. The image will be formed at infinity. So we can see that this image line also makes an angle with lens as theta I over here. So theta O is equal to, when the object is at D, the theta O value is equal to h by d, we can say, because h is the height of the object and d is the distance where it was. So we found theta O. Now we have to find theta I at the same position. Theta I is equal to the same line. You can see from the object's same line, because already we have shifted the object to F. So the object's same position, the image is forming a bigger triangle over here with an angle theta I. So tan theta I, actually we are finding tan theta O and tan theta I. So tan theta I is nothing but, this is HO by D, this is HO divided by F. So what is theta I by theta O? It will be HO by F divided by HO by D. So it will become D by F. So the angular magnification M is equal to D by F. It is slightly lesser than the linear magnification we got for the other case of case 1. But still, this is a position where we can observe the image in a relaxed manner. So here the angle measurements are little confusing, that you have to take it like this. First we have to keep the object, imagine the object is at D, then find the angle theta O, that is HO, that is the height of the object, divided by D, you get the same object you shifted to F, so that the parallel rays will be visible for us, which is in by which the eye will be relaxed way it will look at the image. So the same triangle, same side only, it forms theta I over here. So theta I is equal to again HO divided by F. That is how we get the magnification as D by F.